Today we will be determining congruency using triangles. Your learning target says, I can determine if two shapes are congruent through a series of transformations which will map the images together. Here we have a picture of two congruent triangles. You will notice that we have ABC down here in the lower right-hand corner, and we have PQR up here in the upper left-hand corner. I want you to explain a sequence of transformations which will map triangle PRQ onto triangle ABC, and if you can, come up with more than one solution. So pause me while you're working and then come back to see what I came up with. Here's what I came up with. I translated P to the right 2 and down 4. So in other words, x plus 2, y minus 4, so that it would lay directly on top of point A. And then I drew a line of reflection down through where P and A are joined, and I reflected over it. So I did a translation first, 2 to the right, 4 down, and then I reflected over that vertical line. Let's use the same picture of these two congruent triangles. I'm wondering, is it possible to prove the congruence using only translations and rotations? I want you to think through your options. I want you to play with it a bit, make a hypothesis, and decide, is it possible or not? When you have formulated your answer, I want you to come back and see what I thought. Here's what I thought. I thought no. Just translations would not turn the figure. Remember, that's just a shift. Adding in a rotation would map the wrong segment and angles onto each other, so I don't think that's going to work. Here's a new picture, and we have some coordinates on this one. I want you to show how triangle ABC, which is the top left triangle, is congruent to PQR, which is the bottom right triangle. And I want you to show that congruency with a reflection followed by a translation, and tell me what steps you took. So pause me while you formulate your answer and then come back to check with me. I actually thought up two answers. So in green, I thought if we reflected triangle ABC over the y-axis, then we could translate it 6 down and things would be great. But I also saw if we reflected over x equals -1, which is right here, this line, then we could translate 2 more to the right and 6 down, and we would also be okay. So you have your steps that you took in the last problem. I'm wondering, if you reverse the order, does it still work? So for example, for me, if I reflected over the y-axis and then 6 down, would it still work if I went 6 up and then reflected? So reverse your order and test it and see if it still works. For me, if I moved on the green one, let's check this one. If I moved this 6 down, 1, 2, 3, 4, 5, 6, and I flipped it over the y-axis, it would still work. But on this one, if I went 6 down, 1, 2, 3, 4, 5, 6, and 2 to the right, 1, 2, and then I reflected over x equals -1, it no longer works. So let's not limit ourselves on this one. Let's use rotations, reflections, translations, anything we want. Can you come up with another way to map ABC onto PQR? I want you to pause me while you're thinking, testing, hypothesizing. I guess that's backwards. Hypothesizing, testing. Come back when you have formulated your answer. Here's what I thought. I thought I could translate 2 to the right and 6 down. So that would be x plus 2 and y minus 6, and that would map C right on top of R. And then I wanted to rotate 45 degrees counterclockwise around points R and C. Those would be my pivot points. And in that would make R and Q map onto each other, and then I thought I could just reflect over that line, and it would be great. Of course, as in all of these, there is not one solution, there are many. So if you have a more unique or different solution, I'd love to hear about it.